So here we go again. So today we start by solving a couple of questions from the textbook on section 14.5 about the chain rule of multivariable functions. So in question 1 here, page 943, we have to find dz over dt and dw over dt in the following case, the case where z is equal to xy cubed minus x squared y, while x is equal to t squared plus 1 and y equals t squared minus 1. Of course, here, this is a general question, t squared minus 1, t squared minus 1. Where dw here doesn't exist because we're basically talking about just z. Okay? This is the same question which extends to questions, exercises 1 to 6. So, would you remind us the formula, guys? Anyone would remember the formula used to find the derivative?
Derivative with respect to x?
Yes, so it's dz over dx times
dx over dt.
dx over dt. Anything else you want to add?
Plus,
yes,
dz over dy.
Yes.
And dy over dt.
Okay, beautiful. Thank you, Abdkarim, right?
Yes.
Okay. Okay, so let's compute the, first of all, the partial derivatives, okay? So first of all, let's start with the dx over dt. I'll get how much? I'll get 2t, quite simple. And similarly, I'll get the dy over dt, which is, I guess it's 2t, right? Same way. Okay, now about dz over dx. dz over dx would give me
y cubed minus 2xy.
I think it's going to be y cubed minus 2xy. Yes, you're right. And finally, the dz over dy is going to be equal to I think a 3xy squared minus x squared. Okay, am I right? So now you just plug in these 4 partial derivatives. If you wish, well, you can write it like this. So let's leave it in a simple form. It's y cubed minus 2xy times the first derivative, which is 2t, plus the derivative of y with respect to t.
3xy squared minus x squared.
Yeah, we have the xy squared minus x squared times 2t. Okay. Well, here you can use 2t as a common factor. Just sum up if you wish. And well, I checked the solution here. They wrote they didn't expand. I mean, they didn't place y or x, but their expression for in terms of t. So I suggest. I mean, I would say that definitely there is no need to do that. Here I've just simplified the form. So write it as 2t times y cubed, then plus 3x squared minus 2xy, and finally minus x squared. Okay. So that's it. So that's for exercise 1. Any question on that, guys? That's exercise 1, section 14.5, page 943. Any question? Okay, so it's clear for everyone? Now let's move forward a little bit, and I'll take question 5 on the same page. So I'll write it down. It's question 5, and here, what do we have? We have W, which equals X times E to the power Y over Z. Okay, with X equals T squared, Y equals 1 minus T, and Z equals 1 plus T. So what is asked here is to find the derivative of W with respect to T, of course. Okay, so now here, just be careful. How many variables do we have? How many intermediate, let's say, variables do we have? First of all, you have to recall what is an intermediate variable. Here we said that since X, Y, Z are expressed at the end of the day in terms of T, so the independent variable is T. X, Y, and Z are the intermediate variable, and the dependent variable is W. Okay? So the way to write this partial derivative of W with respect to T would be to write it as dW over dx times dx over dt plus dW over dy times dy over dt, and finally plus dW over dz times dz over dt. Okay, so now if we move forward, let's compute these derivatives or plug them directly. What is the derivative here with respect to x, guys?
E to the power YZ.
Okay. Seems that no one wants to take your place, Abdelkarim, today. So, what is the derivative with respect to t for x? Gonna be 2t.
2T.
Yeah. Plus. Now the derivative with respect to y for w is going to be how much? For sure, I'm gonna keep the ey over z. But if I differentiate now using the chain rule on the exponential here, I have the 1 over z that gets down, right? So I'm going to have x over z times the derivative of y with respect to t, which is -1. Yes? Am I right, guys?
Yes.
Finally, I will add up the derivative with respect to z times the derivative of z with respect to t. Okay? So let's be careful here. You see that z is in the denominator in the exponential. Okay? So I'll get the derivative with respect to z here would be how much, guys? It's minus y over z squared. Am I right? So basically, you're going to get minus xy over z squared, which gets times ey over z. Okay? واضح شباب? Is that clear? The derivative of y over z by the chain rule is going to be minus y over z squared. So you get down minus y over z squared multiplies the x minus xy over z squared. And now the derivative of z is going to be with respect to t equals to 2. Okay? Is that clear for everyone? Any question on this? So that was question 5, exercise 5, page 943, about the chain rule and the use of partial derivatives. Any question?